Hello, welcome back for the third and last part of lesson 5.1. We are working with rational expressions and being able to simplify them. It's a lot of factoring, but we're getting lots of factoring practice, and that's how we're going to think about it. So our last and final grouping has about 10 problems that we're going to work on for extending our understanding of factoring and simplifying rational expressions. 45 is the first one we're going to work on today. And because it has 4 terms, we have to use the grouping method. So we're going to factor out an x, and we have an a plus 2 left over. And then between these two terms, we have a 3 to factor out, and we have an a plus 2 left over. And remember, with the grouping method, ideally what's left over is the same, so that becomes one of our factors, and then this x plus 3 becomes our other binomial factor. And likewise, in the denominator, we're going to do the same thing. We have a y in common, and we have an a plus 2 left over. And then here, we're going to factor out a negative 4, so that we again have an a plus 2 left over. And you can see if we distribute that back through, we get a negative 4a minus 8. So that does work out. And then we have factored fully a plus 2 and y minus 4. And then the a plus 2's cancel. And we have x plus 3 over y minus 4. Okay, the next one is back to the difference of 2 cubes and a difference of squares. So this is a difference of 2 cubes. It's x cubed minus 2 cubed. And then, of course, we have our factoring flow chart. Hidden right here. And our factoring flow chart right here is going to be a minus b times a squared plus ab plus b squared. We're using this one. It's a difference of 2 cubes. So for us, a and b are x and 2. So we have x minus 2 and then x squared minus 2x plus 2 squared. And so that's x minus 2, x squared minus 2x plus 4. And then in the denominator, we have a difference of squares. So that's x minus 2x plus 2. Let's just rewrite that. And then our x minus 2's cancel. And we are left with this. And those cannot be factored any further, because the rule of the difference of cubes and sum of cubes, if a and b are single, like an x to the 1 in the a or b, then they're not going to be able to be factored anymore once you put them into this form here for the difference of cubes or the sum of cubes. Okay, the next one is 53. This one is not too difficult, but this helps us see 53 and 57 help us see just a couple little quirky things with negatives can play. So you can see that x minus 4 and 4 minus x look the same, but they're not quite. So I'm just going to factor out a negative 1 from the numerator. So it's really a negative x plus 4. And then I can say a negative 1, and I can just commute these, so I can flip flop them. So it's really 4 minus x. And then that matches my denominator, 4 minus x. And I'm left with just a negative 1. number 57, and the denominator is something similar. We're going to have, because you can see that the A is on the second piece of the binomial up here. And so that's going to, and A squares in the front piece up here. So we're going to have to pull out a negative. So let's just do that. Let's just pull out a negative up front. And so this is a -1 plus 9a squared. And a -1. And then we're just going to flip it around. So it's the 9a squared first minus 1. And then this is a difference of squares. This is really 3a squared minus 1 squared. So the 3a, so this becomes 3a, the conjugates, minus 1 and 3a plus 1. And now our denominator down here, this is actually a perfect, this comes out to be a perfect square because we can do 3a, it's 3 terms, so we know it's going to be 2 binomials. We need 3a to make 9a squared, and then a -1 and a -1 to multiply to make the +1. And then it's the -3a and the -3a give us the 6a in the middle, the -6a. So it's a perfect, so we can just read right over here. So 3a minus 1 times 3a minus 1. And the numerator and denominator each have a 3a minus 1. And so we're left with 3a plus 1 over 3a minus 1. The next two problems, actually not 61 is the last just simplifying problem that we're going to do. And then I've got a couple of story problems that I would like to do because they're the real life problems that we actually would be working with. So let's simplify this numerator here because this is a subtraction. So let's distribute through the subtraction. We've got x squared minus 4 and then minus a squared plus 4. So right here, the -4 and the +4 cancel. And then we're left with x squared minus a squared. Oh, that can actually be a difference of squares. So we have x minus a and x plus a. And then nothing factors out of here. So it can just go straight over here to be the x minus a. And it looks like the x minus a's cancel. And our final answer is just the x plus a from the numerator. Excellent. I'd like you to get out your book and turn to problem 75 and read through that. And I'm going to get situated and we'll work on some story problems. 75, we're going to look at 75, 77, and 79. So go ahead and get out your book. Okay, here's 75. The following rational function is the one we mentioned in the introduction of this chapter. It is about weight in pounds of a person after X weeks of dieting. And so the X is the number of weeks that they've been dieting, and this is what their weight is going to be. So hopefully after exercising and dieting after 24 weeks, their weight would go down, and it does show that it's going down. The blue are the answers, but we're going to fill that in. So here is the equation, and we are going to fill in the X weeks, and they wanted 0, 1, 4, 12, and 24. And then we're going to fill in their weight in pounds. And I really want us to just get practice. This is using a function. So this is the W of X function, where X is my input. So this right here is like saying W of 0. So we're putting 0 in for X. So 80, 2 times 0 is 0, plus 15 over 0 plus 6 is 6. So it's 80 times 15 over 6. And 5, 2, 40. So this should come out to be 200 pounds. So they weigh 200 pounds at 0 weeks. So this is where we're going to go to Desmos and put this in. So we're going to just put in our equation of 80 over x plus 6. And then up here, it was 80 times 2x plus 15. And we can just go ahead and make a table. And we can see that we don't need, we want 0. So we'll just deleting both of those. We've got 0. And then we said after 1 week, it rounds to 194.29. After we wanted 4 weeks. So after 4 weeks, it's 184. Then you can hit return and do 12 weeks. They weigh 173.3. And then after 24 weeks, they weigh 168. So after 24 weeks, which is approximately 6 months, they have lost about 32 pounds. But just a reminder, you should never just diet. You should also, increase your exercise as well, and vitamins. Okay. So I wanted to look at number 77. So 77, let's just go back to my paper here. So 77 is here. It says test scores. The rational function g of x gives the grade as a percent when 100% is scored on each test, following is 70% earned on the first test. If the 100% is scored on the next 2 tests, find the grade. So the first test was a 70%, and then if they scored 100% on the next 2 tests, so this x would be 2 is what we're looking at, g of 2. What would be their grade, their overall grade? So I have the function here. Okay, so they want to know g of 2. And remember, this does not mean multiply. It's 70 plus 100 times the 2 tests that we scored 100 on over 2 plus 1, because it's an average and we're averaging the 3 tests, and that's why this is a 3. So this becomes 70 plus 200 over 3, and that becomes 270 divided by 3. And it looks like their average grade is a 90%. That's awesome. And then I wanted to look at number 79. 79 is about chemistry. Here. So it says, a solution is created. So back in chapter 4, we did some solution mixtures. A solution is created from 15 grams of sugar mixed into 200 milliliters of water. Another mixture of 8 grams per milliliter is added to the solution. Find the concentration of the solution if 50 milliliters of the mixture is added. The function is given here, so we don't have to do one of those mixture problems like we did in chapter 4, but this is kind of using that same concept. Where x is the amount of mixture added in milliliters, and they told us they wanted to add 50 milliliters of a mixture. So we are going to look at this function at c of 50. So make sure you write down the function. This is number 79. So they want us to look at c of 50. which means we are going to put 50 in for X. So 15 plus 8 times 50 over 200 plus 50. So the numerator becomes, you can do this in Desmos. I like to do things by hand as much as I can just to keep my brain going. 15 plus 8 times 50 is 400 over 250. So the numerator is 415 over 250. I'm going to have to break out the Desmos as well. So 415 divided by 250 gives us 1.66 grams per milliliter. So let me show you that. So 1.66 grams per milliliter. It's important that you've got the units on these story problems. And that concludes 5.1. So catch me back for 5.2.